Welcome back. In this section, we are going to look at interesting interview questions in operators. So let's get started. So first we have to define the blocks, right? So we'll understand how block works and some interview questions in blocks. Let's take the first one. So if you look at it, int k equal to 10, this is actually a auto variable, so it's allocated in the stack. And then you see an open flower bracket, and within that there is again an int k equal to 19. You're printing the value again after the closed bracket, you're printing the value. So I'll let you think about what could be the answer now. So what happens here? The answer is 19 and 10, right? So how does it work? So what happens in the first is when k equal to 10, then there is a stack that opens up where k equal to 10 is stored. Whenever it sees an open bracket here, it opens up a new stack in which k equal to 19 is stored. So this is a different k. Both these k's don't have any relationship. Both are completely different case. So it looks into this value. So k equal to 19. So this 19 is the value which gets printed. Whenever it sees the closed bracket, that particular stack which got opened for this open braces gets killed now. So the original k, which is 10, is the only one that is remaining. So that gets printed. We can check this program on Python Tutor. Let me open Python Tutor and show you this. So we are looking at this program in Python Tutor. So if you look at it, the main, there is a stack. In the stack, there is a k. So this k is defined in the line 4. So let's move forward. In line 4, the value of k is 10. So now if you look at it in line 6, there is a different k, right? Actually, it opens a new stack. In this stack, this k equal to 19 is stored. So if you access k now, it looks at the top of the stack, which is 19. That's what gets printed. So 19 is printed on the screen. When it sees the closed bracket, that flower bracket kills that particular second k that we declared in line number 6. So what is remaining at the top of the stack is only the value 10, which gets printed now. So this is the reason why you get the output. Let's look at one more program which explains the command block now, and then we will discuss the answer. So let's look at this program, a slightly bigger one. Again, it's going to look at a block, right? So how a block works. So here, if you see, you have A, B, and C, three variables here. You have a flower bracket that opens up, and then there is A is 10. There is again a flower bracket. There is again a flower bracket. In this bracket, you have A is 15 and printf %t A, close bracket, int A equal to 9, B equal to 10, and then you're printing the value of A. Again, int C equal to 8, you're printing the value of B and C here, and then ABC. So pause this video, guess the answer, and then we will discuss the answer shortly. So pause the video right now and guess your answer. Okay, hope you have got an answer. The correct answer is this. You can check up if your answer is exactly matching this. Now this is a program we are going to type on Python Tutors to see how it works. Let's get into that. So let's look at this in Python Tutor. So we have int main followed by A, B, and C. So let's go one step at a time. So if you click a forward button, then these three will be initialized, and also you will see the other A's, right? So line 4, you have A, line 4, you have B and C. Then there is a A in line 4. There is a A in line 6, which is this. And there is a C in line 15. So let's go one step at a time. So there is a line 6A, which is actually above the line 4A. So this is the top of the stack. So when it searches, it will look for this. So let's go here. A has a value 10 now. Now if you look at it, one more A is there in line 15, which is taking the priority. So let's look at that. A is 15 now. So now when it prints the A, it prints the value 15, and when the close bracket comes, that gets killed. So that 15 gets printed. Then if you see, there is a new A, line 9 and 10. Here they have got added, right? And now if you print the A, it will print the value 9, right? Okay, so that's done. Int C equal to 8. If you look at C, C is there. This value is 8 now. Line 15's value is 8. Now you are printing B and C. So C value will be 8, and because that's in the top, and then B value will be 0. Yes, so you're seeing 0 and 8. And then when all this bracket happens, all these are closed. What is remaining is this A5, B0, C0. That's what gets printed. So this is the logic, right? Whenever it sees a closed bracket, whatever is defined within that block gets killed. Whenever it sees an open bracket, a new stack opens, and within that, even if it's the same name variable, it can be declared within the new stack as well. There is no problem with that. Within the same block, you cannot have two variables with the same name. So you cannot have one more A below this. That will be an error. But within one block, and this is another block, in this block you can have another A, no problem at all. So this is called blocks. So this is one of the most important ones which is usually asked in interview questions. So in this section now we are going to look at the comma operator, right? If 1, 0, print true, else print false. So the answer for this is actually, you can guess it. Yeah, is it false? Whenever there is an open bracket and closed bracket and you have the comma operator separating variables, the rightmost value is taken. That's the value which pops out, right? If there is no open bracket, closed bracket, then the leftmost value is taken. But if there is an open bracket, closed bracket, it pushes it into a stack, and the top of stack would be the last element, so that comes out first. So again, this is a program int a comma b, a equal to 1, 3, 15, b is equal to in bracket 2, 4, 6, and printf %d a comma b. So for this program, given that you can guess the answer, yes, you can pause the video, guess the answer for this. Okay. So here if you see a is equal to 1, given that there is no bracket, the first value is assigned. Here given that there is a bracket, a stack gets open and the top of the stack would be 6. So 1 and 6 would be the answer for this particular question. Let's move on. So here again you have a comma operator 10, 20, 30. Given that there is no bracket, 10 would be the answer for this. So we saw comma operators. Let's move on with the next one. A is equal to 3 divided by 4. It's a floating point variable. Can you guess the answer for this? If you have guessed it as 0.7, it is incorrect. What happens is, even though it's a float variable, the division that happens here is an integer division. Both 3 and 4 are integers. So when you divide 3 divided by 4, the answer would be 0. So when you store it in A, which is a floating point variable, only 0 gets stored. So answer would be 0, right? Or 0.0, given that we are printing it as 0.1f. So with 1 decimal point accuracy, it's going to print. So that would be 0.0. Again, remember, it's a float variable. Even though it's a float variable, the division is an integer division. So that's why you would have the value as 0. So the modulus operator cannot be used with double, right? So that is 3 mod 4.0 is not possible. Is it true or false? Yes, the answer is true. Modulus operator cannot be used with float and double. So for example, if you are having printf %d 4 mod 3.0, this would result in an error, right? This is not allowed. So you can check it up on the system. It will not allow it. Let's move on with the next thing. So this is again a very interesting question. Many times you would see it. Beginners usually look at it as 4 power 5. It's not 4 power 5. It's exclusive OR operator, right? So if you do an exclusive operator, the answer would be, so 4 we have to write it in binary, and 5 we have to write it in binary. And exclusive operator, the truth table is 0 and 0 is 0, 1 and 1 is 0, 0 and 0 is 0, 0 and 1 is 1. That's the truth table. So the answer for this program would be 1. So let's move on with the next thing. 49 exclusive OR 49. So let's take any number. Say I'll take 5 for example. 5 exclusive OR 5, right? Any number exclusive OR that number would be 0, because 1 and 1 is 0, 0 and 0 is 0, 1 and 1 is 0, 0 and 0 is 0. So any number, you don't have to convert to binary. Any number exclusive OR the same number would be always 0. So next we'll talk about pre-increment and post-increment operators. Very favorite question for the interviews. So let's look at this. Int I comma j, I equal to 22. j equal to I plus plus, printf percentage d j. They're asking you to print the value of j. When it is post increment, what happens is the value, whatever is there in I, gets assigned to j and then it increments I. So 22 will get assigned to j and then I becomes 23. Given that we are printing j, answer is 22. Let's move on with the next one. Int main, int I comma j, I is equal to 45, j is equal to I plus plus. Here we are printing I and not j. So the value of I will be that 45 will get assigned to j and then I will get incremented to 46. So answer is 46. Let's take the next one. Num is equal to 0, 1, 0. Remember 0, 1, 0 means it is octal. So octal for 8. Right? So octal 8 is the value and num plus plus. So 8 becomes 9 and when you print the value, answer is 9. So now again we have the next question. It is pre-decrement. So I is 37, j equal to minus minus I. So when you do minus minus, it means the decrement has to happen first and then the assignment will happen. So 37 will become 36. So I will be 36 and that value will get assigned to j. So when you print j, j will have 36. Next one, I plus 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 I. So when the compiler looks at it, it will say that, hey, I don't know if you're doing a pre-increment or post-increment or what it is. So I don't understand the syntax. So it will throw an error. Next, I equal to minus 2, j equal to 2, k equal to 0, m. So when you do plus plus I, the value of I will become from minus 3, it will go to minus 2. J, when you look at it, so all the unary operators will be done before the logical operators are done. That's the precedence rule. So I will become minus 2, j will become 3 and k will become 1. So all these three values are non-zero values. So m will be 1 because all three are non-zero. So it will be 1 and 1 and 1. So m is 1. So value of m is 1. Value of I is minus 2. Value of j is 3. Value of k is 1. Right? Minus 2, 3, 1 and m is also 1. Slight change here. I value is minus 2 because there is a plus plus I. J value is plus plus j. So it is 3. K value is k plus plus. So for that particular statement, m is equal to, when it evaluates that statement, the value of k will remain 0 and the next statement it will be 1. So what happens here is, given that 1, 1 and 0 is there, value of m will be 0 because it's a logical and all three are 1, only then it will be 1. Here the value of k is 0, so m stays at 0, right? But the remaining values is same as the last question. So minus 2, 3, 1. So the value of k becomes 1 in the next statement when it executes the printf. So before that the value is 0. That's why the value of m becomes 0. Next question. I is equal to 10. Printf percentage d 5 comma 6. C does not throw an error. We have seen this earlier. What happens here is it takes the value of 5, right? And then when you look at the value of for the first statement, value is 5 comma 6. It will take the first value that's there because 5 and 6 are not within open brackets, right? So it is 5 will be taken, and then when you print the value of this one, I value gets first the unary operator gets done. So I will become 11 and that 11 value will get printed on the screen because that's what gets assigned to this. So here you have a variable const int a and it's a global variable, and then you are incrementing that by 1 and then you are printing the value. Any variable which is constant cannot be incremented, so the value cannot be modified, right? So it will be an error. Next one, A, B, C. A is 10, B is 20. C is printf percentage d A plus 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 B. So you have to evaluate this one at a time, right? So B will become 21. So there is no question there. A value of A is 10. So it's printing 2, right? 1 and 0 plus there is a space. So printf returns the number of characters printed on the screen. So one space character is there, 1 is there, 0 is there. So 3 will be the value for printf percentage d. So this value is 3 plus 21 because b is pre-incremented. So 20 becomes 21 plus 3 is 24. So that's the answer, 10 comma 10 space 24. Next one, printf percentage d 7 plus plus. I'll give you a second to think the answer. Okay, the answer is actually an error because 7 plus plus will become 7 is equal to 7 plus 1. You cannot assign 8 to 7. So it is an error. So now we look at the left shift operator. Any value when you do a left shift. So here x is left shifted. So what do you think would be the answer? So when you do a left shift, it is multiplied by 2. So if when you do a left shift by 1, it is multiplied by 2. When you do a left shift by 2, it is multiplied by 4. When you do a left shift by 3, it is multiplied by 8. Left shift by 4 is multiplied by 16. So basically the value, right, left shift by whatever be the number. So 2 power that number is what you have to multiply with. So when it is left shift by 5, 2 power 5 is 32. So you take x and multiply it with 32. So that's how you find the answer. Very similarly, right shift is divide. So here it is 10. Let's take this 5 right shift by 1. So you do a right shift, 5 divided by 2 power 1, which is answer is 2. If you, next one, this is a operator I think all of you would know. It's a ternary operator. So it checks for the value I is greater than 65, and then if it is true, then it assigns 45 to I or L, or if it is false, it will assign 75. So you can guess the answer. The answer is 75 because 65 is not greater than 65. Let's look at this. X equal to 5. Print the value of x. So 5 will get printed. X left shift by 2. So when you do a left shift, as I said, you have to multiply by 2 power 2, which is 4. So 5 4s are 20. When you do a right shift by 2, 5 divided by 4, which is 1. So that's what you see here. Next, if d equal to k equal to 1, d equal to 1, percentages, true or false. Again, you know this is the operator that we already discussed, ternary operator. The value of k is 1, it returns true, else it returns false. Here the value of k is 1, so it returns. So let's look at bitwise OR and bitwise AND, how it works. So in this program you have a as 44, a equal to 44 or 1. That means the last bit in 44 is getting changed to 1 in binary. It becomes 45. Now when you do a and equal to 1, what happens is, except for the last bit, all other bits are set to 0 and it gets compared, right? So what happens? It will be only 1, correct? That would be the answer. So a and equal to 1 will reset all the bits. If at all the last bit is set, then the answer will be 1. If the last bit is 0, it will be 0. So here the answer is 1. Let's get on with the next one. So now this question, you have integer a as 4, a star equal to 4 plus 1, printf percentage d a. So you can guess your answer, how it works. Okay, so now how it expands is a equal to, first the 4 plus 1 right side gets evaluated. So 4 plus 1 becomes 5. And then it does a star equal to, that is, it will multiply the value of a with the 5. So value of a is 4. So 4 into 5 is 20. That would be the answer. Now multiplication has a higher precedence than addition. But even then, star equal to is an assignment operator which has the lowest precedence in the entire thing. So assignment operator has the least precedence compared to all the other operators. So what happens is the addition operator has a higher priority. So 4 plus 1, 5 gets evaluated. 5 into 4, 20 would be the answer. I have seen many students actually look at it as 4 into 4, 16, and then they will say 17 is the answer. Nope, here it is 5 into 4, 20 would be the answer. Next question, here you have the tilde operator or the ones complement operator. So you have n is 7. N is equal to tilde of n, that's the ones complement, and then you print the value of n. So here, right, Let's see what happens. I want you to guess the answer. Okay, the answer is -8. So if you get any number, let's assume you're getting 100, answer will be -101 when you do this. What really happens? Let's understand this, right? So you have 7 being represented as 000000111. This is a signed integer. That is, the leftmost bit is representing the sign. So signed integer. When you do a tilde, it changes to this 111110000. So that means all the ones are getting to zeros. That's what is a signed integer. I have taken only 8 bits here, but ideally for an integer you will have at least 32 bits. Anyway, now what is this number? 111110000. You all know 100 is a 8, right? And this represents the minus sign. So answer is -8. This is how signed integer negative numbers are represented in C. That's why it's -8. Without the details, you can just simply take any number. If they do a tilde of it, then it becomes one number extra and sign changes. That's all it is. Let's get on with the next question. A equal to 10, B equal to 0, C equal to 5, integer D. D is equal to A equal to B and B equal to C and C equal to A. Now what really happens is it does not do a comparison. It does not do A and B comparison. The value of, when it does the first A equal to B, it takes the value of B, which is 0, and assigns it to A. Then a really interesting thing happens. Given that value of B is 0, which got assigned to A, the first part of the evaluation, D equal to A equal to B, right? When it has evaluated that part, that value is 0. So if you know in a logical AND, even if one value is 0, the entire expression is 0, which is false, right? So what C does is it will know that, yeah, I don't have to evaluate the remaining things. Anyway, it is going to be 0. So it does not do B equal to C and C equal to A. It will stop with A equal to B because the value of B is 0. Just in case the value of B was 1, in that case A will be 1, B will be 1, and it would have evaluated B equal to C, right? But given that A equal to B and B is 0, it will not do the B equal to C and C equal to A. Those two will retain the values they already had. So here the answer would be A will have a value of B which is 0, A will be 0, B will be 0, C will be 5, and D will be 0. So you can check this, you can run the program and see, and this is called shortcut, right? So this is called shortcut in AND. Similarly for OR, if the first argument evaluates to 1, it will not do the remaining arguments, because for OR, even if one value is 1, the remaining need not be checked. So that's how C works. So very popular interview question, how do you swap two variables without using a third variable? So there are two approaches to this, right? So let's look at both of them. We'll get on to online GDB to discuss the answer. So let's get with the answer. So A has a value of 3 and B has a value of 4. So first what you do is you save the total in A, that is A equal to A plus B. So A will have the value 7. Then you do B equal to A minus B. So B, now if you see A has 7. So 7 minus B, the value is 3. That will be stored in B. A still has a value of 7. So again A equal to A minus B. A will have 7. So you subtract the current value of B, which is 4. You will have answer as 3. So let's run this program. You will see A is 4, B is 3. It has swapped the values. So this is one approach. The other approach is using the exclusive. So let's look at the second approach. What we do is we use the exclusive OR operator. A is equal to A exclusive OR B. B equal to A exclusive OR B. A equal to A exclusive OR B. Let's run this. So if you see, it has swapped. This is the second approach as to how it works. So you can try out, right? So let's do this step by step. When you do A equal to A exclusive OR B, I'll do it in binary. So the value of A is 3. So A is this. B currently has 0, 1, 0, 0. Now if you do an exclusive OR, the result we are saving it in A. So A will become 0, 1, 1, 1. Okay. So this will be the first step. Second step is we are saying B equal to A exclusive OR B. So A is currently 0, 1, 1, 1 and B is currently you have 0, 1, 0, 0. Now if you see, if you do an exclusive OR of these two things, B will be 0, 0, 1, 1. Correct? That's the exclusive OR operator. So now if you do the third step, right, A equal to A exclusive OR B. So A has a value of 7, which is this. B has a value of 0, 0, 1, 1. And the resulting A will have 0. Second digit is 1. Third is 0. Fourth is 0. So finally, you have an answer where B has a value of 3, A has a value of 4. This is how with the exclusive OR operator as well, you can do the swapping, right? Net your program looks like this. I'll show you the program. So this is again a famous question, right? Sometimes they will say that you cannot use the plus operator, but still you will have to do the same operation. Again, right, when there are two variables, instead of using plus operator, you can also use exclusive OR operator to get the same result as plus. So if you look at it, the same thing has happened here. A equal to A exclusive OR B, B equal to A exclusive OR B, A equal to A exclusive OR B. That's it. This is a second approach in which you can swap two variables. So the next popular question in the operator section is, how do you find if a given number is even or odd without using the modulus symbol, right? So I'll have a variable A. Let's take it as first as even. So the way to do it is, if A ampersand 1 equal to 1, printf, it is odd. Else it is actually an even number. So what is the logic here? Let's look at that. So I'll first run it and then show you that it works. So 3 is odd. I'll give 7. 7 is odd. I'll give 18. 18 is even. 36. 36 is even. Right, so this is the logic. So how is it working really? So if you take any number, odd number, 0, 0, 1, 1, which is 3, 0, 1, 1. So let's take 1, right? So let's take 5. So if you look at all these numbers, the last rightmost bit is 1, right? And let's look at even numbers, 0, 1, 0, 0, 0, 0, 1, 0, 2, 4, 8, right? So 6, if you look at all these, or 12, these are numbers, if you look at it, all these are even numbers, last digit is 0. So that's the difference between odd and even. So what we are checking is the last bit. If you AND it with 1, it means the last bit I am checking. If it is 1, then it means it's an odd number. If the last bit is 0, then it means it's an even number. That's the logic that we have used here. So this is one more way. The other way, as all of you already know, is using the mod operator, mod to equal to or not equal to 0. Then it is odd, otherwise it is even. This is the second approach to do the same thing. Next question is, what is precedence and associativity, right? So precedence, all of you know in this particular case, right? I equal to 3 plus 4 star 2. If at all you have to calculate the answer, in this case you would do 4 into 2 first before you add 3 to it, right? So the answer would be 11 and not 14, because you would do only 4 into 2 first. For the first question I'm saying, right? 3 plus 4 into 2 without the brackets. 4 into 2 would be done first before you add 3, because the precedence, we all know the Bodmas rule. Precedence is first given for multiplication before you do addition. So 3 plus 8 would be the answer here. But if at all brackets come in before that, so brackets take a higher precedence than any of the other operators. So in the second case, 3 plus 4, brackets within brackets, so it does that first. So 7 into 2, 14 would be the answer. This is precedence. In case of associativity, let's take this example. 3 into 4 / 2 or divided by 8. So if you do this, 3 into 4 divided by 8, here the precedence is same, right? Both for star and / or multiplication and division have the same precedence. Which one to do? That's where associativity comes in. Associativity states that depending on the operators, whether to proceed left to right or right to left. Let's look at this example, right, to understand what is left to right, what is right to left. So if I am going from the equal to operator towards the semicolon, that's called left. So in this case, 3 into 4 will get processed, 12 divided by 8, answer would be 1. But in case this is called left to right, right? The other case is the same question. If I go from semicolon to that equal to, right, that is right to left. That means 4 divided by 8, it will make it as 0 because it's in integer division. And you're multiplying by 3, so the answer will be 0. This is called right to left associativity, right? So in C, which associativity does it follow? It depends on the operator. So for multiplication, division, modulo, addition, subtraction, left shift, right shift, less than or equal to, greater than or equal to, not equal to, bitwise and, bitwise or, bitwise exclusive or, all these operators go left to right. This is one. Second thing is, we have certain operators which are right to left. For example, prefix, increment, decrement, unary operators, negation operators, size of operator, dereference operators and pointers, ternary operator, assignment operator, all these go right to left. For example, in an assignment operator, only if the evaluation, whatever is there on the right side of the expression gets evaluated, that value can be assigned to whatever is on the left. So naturally, assignment operator is a right to left operator. So this section covered associativity and precedence. Associativity comes in only when the precedence is same. So for both the operators, the precedence is the same. Which to evaluate first, that's defined by associativity. It varies by the operator. For certain operators, it is right to left, and certain operators, it is left to right. That's what we saw in this section. So that brings us to the end of this section. Hopefully you enjoyed it. There are a lot of questions that are usually asked in C aptitude or during the technical interviews. We covered them, we discussed the answers, we also discussed the concepts behind them. Hopefully it was useful. If you have any comments, leave your comments in the comment section. Thank you.